Physics by Jaron Schreiber. Specific heat capacity and latent heat. This is defined as the amount of energy needed to raise or lower the temperature of something by 1 degree Celsius or Kelvin. Now, why does it not matter if it's in Kelvin or Celsius? Say we have some ice at 0 degrees Celsius, and it rises to a boiling temperature of 100 degrees Celsius. It increased by 100 degrees. Now, if we convert each of those temperatures to Kelvin, the difference remains 100, only now in Kelvin. This is true due to the linear relationship they have. These are the formulae you'll need to know. The energy, or heat, needed to change something by a certain degree, measured in joules, is equal to the mass times specific heat capacity times that very change in temperature. You can rearrange this to be equal to specific heat capacity, mass, or change in temperature, but you really only need to know one of these. Also know that that same energy is equal to mass times latent heat. That latent heat is the energy needed to change from a solid to a liquid to a solid, a liquid to a gas, and a gas to a liquid. Lastly, we have that same energy equal to the amount of power applied times the amount of time it was applied for. These three formulae can all be set equal to each other through Q, our energy or heat. Now for some examples. We have 3 kilograms of water that starts off at 90 degrees Celsius and cools down to 10 degrees Celsius. How much energy or heat was released? First, know that the specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. Take the first formula, energy or heat, is mass, 3 kilos, times specific heat capacity, 4,200, times the change in temperature. As previously explained, this change in temperature is the same regardless of whether it is in Celsius or Kelvin. So this is 90 minus 10, or 80 degrees. Multiply it out, and we get 1,008,000, or 1,008 kilojoules. That is the amount of energy given off, because it was cooling. Say if this was heated up, from 10 to 90 degrees, it would still be 1,008 kilojoules, but that would be the energy received, not given off. Here we have a kettle applying 4 kilowatts of power to heat up 270 grams of water. Right now it's at 18 degrees Celsius, and how long will it take for the water to reach 318 Kelvin? Also, the specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. First and foremost, always check your units. Temperature should be in Celsius, power should be in watts, and grams should be in kilograms. For this, we'll use the formula for specific heat capacity. We know that energy is also equal to power times time, so we'll set the two equal to each other. Plug in all our values. The change in temperature is 27 degrees, divide both sides by 4,000, and we get 7.65 seconds. For this last example, we have 20 grams of ice at negative 20 degrees Celsius. Now how much energy is needed to turn it into steam at 100 degrees? We first need to look at how the temperature will change in this process. We are assuming no sublimation here. We're not directly going from a solid to a gas. So we need to pass through all these different stages. The energy to go from this state to this state to this state and so on, all added up, will be the energy needed to cover the whole thing. We'll start at negative 20 degrees Celsius, so this would be ice. It would have to melt at 0 degrees Celsius. Remember, this is considered both the freezing and melting temperature of water, depending on which direction you're going. And to get here, we apply this formula. Mass times specific heat capacity times change in temperature. It is in this little space here that we have ice and water coexist. There's no change in temperature necessarily. However, we are changing states, and the formula for changing from one state of matter to the next is the latent heat formula. Mass times latent heat of vaporization or fusion. Now we heat up to boiling temperature, where both water and steam can coexist. So when we rose from 0 to 100 degrees Celsius, that was a change in temperature, so we use this formula. In this final stage, we use the latent heat formula because there is no change in temperature, simply a change in state. The mass never changes, it remains 20 grams. The specific heat capacity of ice is 2.1, it goes from negative 20 to 0 degrees Celsius, so the change in temperature is the absolute value of 20 degrees. We get 840 joules. Here we are going from ice to water, staying at 0 degrees Celsius. The latent heat of fusion, or melting, of ice is 334. We get 6,680 joules of energy. The specific heat capacity of water is 4.18. we have a change of 100 degrees Celsius. This requires 8,360 joules of energy. For the last stage, the latent heat of vaporization of water is 2,260. So to go from boiling water to steam at this instant requires 45,200 joules of energy. All that's left is to add up the energies required to go from one state to the next, and we get 61,080 joules of energy. Look forward to many videos in the future, but in the meantime, make sure to subscribe and enable notifications so you can see when these videos get posted.